Howdy.
There you go. That's exactly how
That's Jay Short in a nutshell.
That's quality.
Are there any questions? Are atoms really like apples? These are the important questions. Speaking of important questions, how'd that work though? Did you have any questions?
It was fun.
What is Solidworks?
And there's always that side.
What is SolidWorks really? I mean,
Is it a particle or wave?
I feel like it exhibits aspects of both. It's
Depending on the experience.
it's impossible to know for sure. But unlike things that are impossible to know for sure, did you have any questions in the homework that you'd like to discuss? Did it go well?
Number 3 was fun.
Cool. Number 4 was fun and or boring, depending on what you did.
Yeah.
My favorite so far was seeing all the people that submitted the example that we did in class. It's totally fine. I mean, that's not exactly the spirit, but I will allow it. Do you have any discussion you'd like to have about the homework, or do you feel like you're ready to move on? Let's get going. Okay, well, we had spent last class getting more proficient at SolidWorks basics. Today, here on SolidWorks Day, quote, 2, unquote, we are going to be taking our third look at the software. We had spent the first day talking about how to set up drawings, how to set up sketches, how to reference planes. We had done a little bit of extrusion. On our second day, we had put a bunch of time into linear extrusions and linear cuts and tried to get your head wrapped around the concept of there are multiple ways to approach the problem. And generally speaking, there isn't a best solution. There are better ways to do things than others. There are best practices. There are common ways of approaching a type of problem, but it isn't necessarily set in stone. What I want to do today, here on our third actual day of SolidWorks, is going to be to talk about revolved extrusions. So under the Features tab, next to Extruded Base, you have Revolved Base. And once you have Material in SolidWorks, you also have the Revolved Cut. The Revolved Base and the Revolved Cut both reference rotational symmetry. So let's say for a moment, we wanted to draw a sphere. Like we spent a bunch of time, we made a cylinder, we made a cube, we made a rectangular prism that wasn't quite cube-like. Let's say we wanted to make a sphere that was 100 millimeters in diameter. Using what you know so far, you might be tempted to draw a circle on one of the planes and then extrude it. Like, for example, if you were to do something like, well, if we draw a circle with the origin in the center, and then we make the diameter of the circle 100 millimeters, and then this needs to be a sphere, so it's also going to be 100 millimeters in the front to back direction. So if I midplane extrude 100 millimeters, then I have a sphere now, right? Oh, wait, no, that's not a sphere. Okay, I got this. Guys, don't worry, I got this. I can cut it from the right side. I'll just draw a circle, and then I'll cut around that. John showed us last time how we can cut around a shape, so I'll do the same thing again. I'll make a circle, I'll put the origin in the center, I'll put the outside edge tangent to one of the surfaces because I define that as being 100 millimeters across, therefore the circle will have a diameter of 100 millimeters. And then I'll go up to Features, I'll go to Extruded Cut, and then I'll cut everything around the circle. I want to flip side to cut, I want to cut through everything in both directions, and now we have a sphere, right? Oh, look at our beautiful sphere. Oh, no. Okay, I know what I'll do now. I'll draw from the top. Okay, I'll draw another circle. This time on the top plane, I can draw a circle with the origin in the center. I'll go out, I'll establish that the outside edge is tangent to one of the sides, which is still a square from this projection. I'm sure this will solve this problem forever and always. I hope so. Fingers crossed. I'll flip cut on the other side. I'll go through everything in both directions. And now we have a sphere, right? Oh, no, we still don't have a sphere. We have a weird-looking paper lantern thing. Okay, so I know what I'll do. I'll add a bunch more reference planes, and I'll just continue to take circular cuts. All I have to do is approach infinity, because as my number of cuts approaches infinity, I become more and more sphere-like. We can establish a limit, right? I mean, we just invoke a little L'Hopital rule, and we'll be fine. I don't understand what the problem is. If you don't want to create an infinite number of cuts here, the easier way to draw a sphere would be to recognize that the sphere has rotational symmetry. So instead of drawing a circle, I'm going to draw half a circle. I'm going to draw it on the front plane. I'll take my circle that I created earlier. I will cross it like this. I will get rid of one side of it. And now I have half a circle. So if you were to imagine spinning that half a circle around this vertical part of it, anything that was swept through space would have material left behind, and therefore I would be left with a sphere. In terms of best practices, it is good to establish an axis around which to revolve. So I'm going to draw another line, even though it isn't explicitly necessary, just to indicate what I'm trying to do. So I'm going to draw a vertical construction line that is infinitely long. NVD, I'll just click into space arbitrarily. I'll then exit. I'll click the line. I'll control click the origin if it'll let me. And then I will establish a coincident relation. Now I have a fully defined axis for my circle or semicircle to revolve around. Now, this time, instead of going up to the extruded base, I'm going to go right next to it, to the revolved base. Whew, I know. Now, when I click revolved base, it actually wants two things. It wants a contour that's an enclosed region to sweep around and leave material behind with. It also wants an axis of revolution. But SolidWorks is pretty smart. It says, hey, you created an infinitely tall construction line. I bet that's your axis. And I say, you're right, SolidWorks, well done. And it says, you only have one enclosed region. I bet that's going to be your contour around which you want me to spin that axis and create material. And I say, you got it, SolidWorks. If I wanted to micromanage SolidWorks, or if for some reason any of these fields weren't pre-populated, I could click into the box next to the axis of revolution indicator here and click the construction line I had created earlier, and then click into selected contours and click this semicircle. Now when I click OK, I have an actual sphere. Ooh, it is revolutionary. So I'm guessing if you're following along, that probably went well, right? For those of you who had errors, did it say something like no enclosed region? A pretty common mistake when creating revolved extrusions is for people to forget to close half their cross-section. So looking at this semicircle, if, for example, you left this line behind and you only created half a circle, your circle isn't going to have an enclosed region to sweep. So when you attempt to create a sphere like that, you end up with a broken extrusion. Don't forget to enclose your regions. Another mistake that you may have made if you are approaching this for the first time is how far to extrude. So in my revolved extrusions, I have it set to extrude in one direction, 360 degrees. By default, SolidWorks sometimes pre-populates to 180 degrees, which creates half a sphere, which if we had created an entire circle on the front plane would actually work out just fine. But just be aware. Just like with the linear extrusion, you can create mid-plane extrusions that maybe only go 5 degrees in one direction. If you were trying to create like teeth on a gear and you wanted to pattern those teeth out, it might make more sense to have only 5 degrees of extrusion as opposed to a 360 degree extrusion that you then cut. Does that logic make sense?
Yep.
Okay, we made a sphere. Hooray for us. What if I wanted to create a donut shape? Let's imagine that from the top, our donut shape looked like this. Let's say the inside was 2 inches across, and the outside was 6 inches across. What is the diameter of the circle that I'm going to draw on a sketch to revolve? Radius? Okay. What is the radius of the circle that I need to draw on one plane and revolve around the center of my donut?
Semicircle.
Okay, we can't just keep answering questions with more geometry. I mean, I will allow maybe one more. If you want to correct me and say that this isn't a donut shape, it is in fact a torus, that's fine. We can get into the technical terminology. But the point is, in order to create this shape, I'm going to go back into the front plane. I'm going to draw a circle. And on this circle, I'm going to have to establish a dimension. We cannot procrastinate forever. What do you want the diameter of that circle to be? 2 inches? 0.5 inches? Do we have enough information on this drawing to know that? We do. How do we figure it out? Yes, we figured out with geometry. That's right. You're going to take 6 inches, which is your entire circle, and what you want is specifically this distance, so you subtract 2 inches, which is 4, you divide that by 2 to represent either side. So 2 inches is the name of the game. Now, a slightly more complicated geometry question. I'm going to draw another vertical construction line at the origin, and I'm going to position the center of my circle away from that axis of revolution. How far should that center of that circle be from the axis of revolution? 4 inches?
2 inches.
2 inches. Anyone want to vote into camp 2 or 4?
3.
Okay, we have 4, 3, and 2 as options. Let's think through this. The center of my circle is going to be located here. Because my circle is 2 inches across, this distance here is 1 inch. So half of 6 inches would be the distance from the center out to the edge, which is 3. And then you subtract 1 from 3 and you get totally 2, right? That's the geometry we're referencing. So I'm going to put in 2 inches. You may be noticing that my unit system is in millimeters, but the dimensions on our drawing are inches. If I forgot how to switch my unit system, would you guys help me out? Bottom right-hand corner totally works. I can switch that into inch pound. The longer way of doing it would be to go up to Tools, Options, and then under Document Properties, Units, and you can select whichever distance you like your default to be. Now, 2 inches and 2 inches seems like we are made in the shade. How come that circle's still 0? No, hold on. Let me ask that question again. How come that circle's still blue?
Because you haven't defined it.
Yeah, easiest way to figure out what isn't fully defined is just to grab it and try to drag it around. So if I grab the center of the circle and drag, I can see that it's not constrained in the vertical dimension. I have nowhere to put it specifically, so I might as well arbitrarily decide that I want it to be horizontally aligned with the origin. That would put the origin in the exact center of my donut. Now I have a fully defined shape. Now I go back up to revolved base, and I have a torus. We did it. Congratulations are in order. I would congratulate you with a donut, but unfortunately I have no donuts. Do you have any questions so far? Unfortunately, Solidworks isn't set up to do artsy sort of things very well. So if you wanted to try to add sprinkles to the top of the donut, what you would end up with is a very well organized pattern of sprinkles, which, you know, I'm not trying to imply is good or bad, but it is something that probably isn't representative of what you actually want. For example, if I really wanted to do that, being as we're here learning stuff, I could draw on the top plane, I could draw a couple arbitrary, I don't know, what shape is a sprinkle? Maybe an ellipsoid?
Yeah.
Okay, I'll draw one of those, I'll draw one of these, I'll draw maybe a nice like ellipse. There, that looks like sprinkles. Now I will do a circular pattern, which we haven't talked about yet, and I will add, it looks about good. Then I can extrude up. Let's go with offset from the surface of the donut. Let's offset it by 0.25 inches. This is probably going to fail because it doesn't know if I mean up or down. But what is life without a little risk? Especially when you are adding sprinkles to donut shapes. Okay, that's not what we wanted. Let's go the other direction. That's much more better. That looks appetizing. Yeah, you're right. That doesn't look, those look a little bit too tall to be sprinkles. Let's go with 0.05 inches. Now that is much more better. Look at that donut. It is delicious. Do you have any other questions or ridiculous requests to make to the donut? Yes.
Can you color them?
Okay, we're getting a little outside the scope of the example problem. If you are curious about applying different colors, that's not something we're going to cover in this class because we're focusing more on the substantial part of the modeling part and not the artsy side. But if you do want to change color, if you go over here to this little colored sphere looking thing on the right, you can change the appearance of things. There are some pre-populated appearance settings, like for example, if you wanted, oh, I don't know, a low gloss plastic of blue to be one of the sprinkle shapes. I can drag that out over the shape, and I can specify, do I want that to apply to just that one sprinkle? Do I want it to apply to the entire extrusion, or do I want it to apply to the entire body or the entire part? So in this case, maybe the sprinkle, and let's go with a nice yellow plastic for the donut itself. Now that looks like a cartoon donut, much more better. Did you have a question or?
Yeah, can you make a bite mark?
A bite mark? Oh, that's a good point. If we wanted to create a bite mark, one of the ways that we could do that would be to draw a sketch on the top plane, maybe something really semicircular. For the moment, let's take the assumption that our bite is perfectly circular. That is, the person taking the bite has no teeth. Now, I would say my jaw is like 2.5, 3 inches across. So let's go with like 2.5. No, that doesn't seem quite right. Although this donut is just arbitrarily sized. So let's go with 3 inches. And then I want this to be a real specific location. So I'm going to draw an infinitely long construction line that is positioned from the center. I'm going to add another construction line that goes from the center to the center of the bite. And let's say that this bite was positioned 30 degrees off of the horizontal. Now, when I cut through everything in both directions, I end up with a nice piece of material removed. Now I know what you're thinking. You're thinking, but John, that doesn't quite look like an actual bite shape. You see, John, when people take bites, they don't just move their teeth vertically and remove material between them. So that's a fair criticism. If I wanted a more realistic bite shape, it might be better for me to draw something with some rotational symmetry. So let's try that. If I instead wanted to create a bite shape that was revolved in order to create that illusion of being an actual jaw with teeth removing material, I could draw, for example, on the right plane, and I could draw the shape that I want to remove. Let's use an ellipse because ellipses are neat. And let's say that it looks something more like this. So I've arbitrarily sized this. I can apply some dimensions so at least it's fully defined. Because remember, best practice says we should fully define our arbitrary bite marks out of the shapes that we are just playing with. So 2.625, that seems about right. Let's position it horizontally off the center at a position of 3.8. Now I need to constrain its vertical position, so I will apply a horizontal relation to the origin, and I need to position this orientation of the ellipse itself. Now that it's horizontal, it's fully defined. Now, if I were to try to revolve this around an axis, maybe an axis that went through the center of the ellipse, like, say, this, that isn't fully defined yet. Let's add a vertical relation. Now it's fully defined. Let's create a revolved cut. So I'm going to revolve around that line of construction. If I revolve half of it, I can revolve 360 degrees. If I revolve the entire thing, I can revolve up to 180. It doesn't really matter since I'm removing material from the donut. Let's remove it from one side only, and we end up with something that looks like, yes, hey, look at that. I didn't close my region. Gotta close your region when you're creating bite marks. And, I can trim off the back just so that I don't get confused. So if I go back up to revolve cut, revolve around that arbitrary center line, there, that might look like a more realistic bite mark. Maybe I want to make it a little bit deeper. I mean, maybe something more like that. And I could fine tune that a little bit more. Maybe make this like 1.875 instead of 1.75. It's a shame I didn't bring the calipers to measure my jaw, but, one thing at a time. Any other requests?
Jelly-filled donut.
So if I wanted to create a jelly-filled donut, one way of doing that would be to add another body inside the center of my donut. If I establish a cross-sectional view here, that is, if I were to cut the view of my donut in half, right now I see that I have this solid yellow plastic cake material through the entire thing. And it might make more sense for me to replace part of that with another body. So you'll notice that I drug off my bite mark. That was because I'm going to be modifying the body of the donut, and then I'm going to apply the bite mark, the cut, to the entire thing. I don't want to add the jelly after the bite mark, otherwise there's going to be jelly that I somehow didn't bite through. And that's unrepresentative. If there's jelly, I bite through all the jelly. Everyone knows this. So I'll go all the way back to my initial revolve. I did that by dragging this blue line in the hierarchy up. So now I'm looking at the revolve, and the sprinkles nor the bite mark have been applied yet. So I could add another modification to this sketch, and it'll go through the process of rebuilding the rest of my features to the completed extrusion. So let's go with a... That is a lot of jelly. What do you suppose the cross-sectional area proportion of jelly inside of a donut? I mean, I would say that it's more accurate to describe it as a proportion of the area than by a raw dimension itself. Maybe the area is 1/3 jelly, maybe it's 1/2, but for the convenience here, let's say that the diameter of the entire section divided by the diameter of the jelly represents a proportion of about half. That would give me 1/4 of the cross-sectional area because I'm squaring 1/2. So I'll draw another construction line across the section from the edge of the cake to the edge of the jelly. I will tell Solidworks these are definitely construction lines, they should be collinear, and they should be equal. Now I've created a cross-section in the center that is going to be removed from my extrusion. Something like this shape. So right now, again, if I cut it in half with my cross-section view, you can see that I've created the hollow cake. Now I'm going to add a separate body for the purposes of art. That is, of course, ridiculous, but hopefully we're learning something from this exercise. I'm going to draw on the front plane. I'm going to switch to a hidden view. I can see that cutout that I had created earlier. I can draw a circle that is going to be concentric with that cutout we had created earlier. And let's say for the moment that there is actually an offset between the edge of the jelly and the edge of the cake donut. So let's say that that distance was something like 0.02 inches. Now, as long as they have the concentric relation, that should fully define my inner circle because they're sharing the same center point. Now I'll add another axis around which to revolve. It's infinitely tall, a construction line and vertical. Now when I exit my sketch, flip back into seeing everything with a cross section, and then add a revolved extrusion using that new sketch that I created. Now I can create that extrusion around the entire shape. I'll just select that contour just for good practice. You'll notice we have a nice gray filling. Let's maybe switch that to, I don't know. Oh, let's go into something with a textured look. Oh, that's disgusting. Maybe a matte, no, matte, okay, maybe wax. Let's go with a dull wax appearance. Of course, can't do that in that view. That would make entirely too much sense. Let's drag down and get my sprinkles and jelly back up. You'll notice that the bite mark didn't remove from the jelly. I have to tell it that I need all the bodies to be cut, not just the outside cake part, because they are separate bodies. Now I'll add the dull red wax color to the inside, and I have to actually select, if I want it to be just that extrusion, the entire face, the entire body, the entire part. Body is representative because I left that as a separate semicircle. Okay. Did we learn any from that example problem? Yeah, I'll just generate an STL file. If you are curious about how to generate STL files from which to generate G-code for 3D printing, you go up to File, you go to Save As, and then instead of saving it as a SolidWorks part, you save it as an STL file. I will point out that you want to make sure, generally speaking, that you have it saved as a SolidWorks part file before you export the STL, because the STL file loses all of the intelligence of the SolidWorks part. Like, the convenient thing about this is that the SolidWorks part is generated every time I open it. If I go in and change something like, I want the outside of the donut to be 2.25 inches across instead of 2, I could do something like this, and it will rebuild the entire rest of the part around that new dimension. With an STL file, you have very limited control because the STL file doesn't know that it's a cylinder. It doesn't know that it's a torus. It doesn't know that there's a linear extrusion here. All it knows is the edges of polygons. So be aware of that. Something else I'm going to make you do in the homework is, in addition to submitting your SolidWorks files as SolidWorks part files, I also want you to submit an image. The way that you do that is, when you are saving your SolidWorks part file, you do the following. You go up to an isometric view. That's this view here on the view window. I'm going to pause to make sure that you all see where I'm about to click. This isometric view. And then you're going to go up to File, Save As, and instead of saving as a SolidWorks part, you are going to save as a JPEG. So one of the options here is a JPEG file. and it's going to generate a JPEG from your current view, which if they are all isometric views, you should end up with a nice looking image for all of your parts. So again, you save your part as a SolidWorks part, and then you save an image. And here's why that's useful. If we are looking at the File Explorer, and you have thumbnails created from your images, you can immediately see a nice looking thumbnail of that part. By doing that, you can have a visual reference for what your part looks like, and when my grader is trying to figure out which part in your homework is associated with which problem in the homework, they can immediately see which one is which. So in your homework assignment, which opens up in 4 minutes, you have to submit a SolidWorks part file and an image file for each of the problems in the homework. Do you understand?
From now on or just for that one?
From now on. They will be explicitly marked in the homework, but for the rest of the SolidWorks homework assignments. I didn't want to do that in the first homework assignment because it seemed like too much too quick. Any other questions? Okay. For our next exercise, let's try to create a representation of this aluminum can that is housing Delicious Bang energy drink. Let's say that I wanted to create a model of this can. I could create it with linear extrusions, a sequence of linear extrusions. I could create an extrusion from the bottom, go up maybe a couple of millimeters, create an extrusion that went out, and then try to trim that off, create a circular extrusion that went up and then back. But it's way easier to recognize that this can exhibits rotational symmetry. Therefore, if I wanted to try to model this part, I could go up into the infinite void and stare at it for a second, look at the cursor as it bounces around through space, switch back to SolidWorks, and close out my ridiculous donut file. Go up to File, New, Part, and I could start to draw half the cross-section of my can. So I don't have a pair of calipers here, as evidenced by the discussion of my jaw size. Let's instead just imagine some dimensions. So I'm going to arbitrarily represent the bottom as being me bottom is the center of my origin. And I'm going to come out a little bit, go down, over, back up a little bit, up for most of the height of the cylinder, back in with a little bit of an angle, in a little bit to represent that lip, come down just a hair, and then back over to above the shape of my origin. So that's a whole bunch of geometry. And by creating it as a sequence of lines first, before I start adding dimensions, I have something around which I can kind of visualize what I'm doing. So I can go through the process of applying dimensions to these shapes. For example, I could say that this bottom section is probably a diameter. If I wanted to reference a diameter, despite the fact that I'm drawing half the cross section, if I draw a construction line that is vertical and infinitely tall, I can reference the distance out to the construction line like this. And now when I drag it to the left of the construction line, whoa, did you see that? That was cool. I'll do that again. If I'm dimensioning to my construction line in the center, and I'm trying to apply a dimension here, and I drag to the left of the construction line, whoa. So in the event that you're drawing half of a cross section and you want to reference geometry that is across the entire thing, SolidWorks is pretty smart about that. So let's say that the bottom of this can is 1 3/4 inches across, something like that. So 1.75 inches. I see that my distance right now is given in millimeters, so I'll switch that up to inch and pound, go back into my sketch to edit it. Now I can continue the process of establishing some dimensions. I can see that the can is maybe 2 3/4 inches across, so I can apply a dimension to the center line, and then again back, maybe 2.75. Then I can start the process of establishing dimensions up. Let's say that that distance here is maybe 1/4 inch. The distance of this bottom lip, let's establish that is also 1/4 inch. Let's establish the bottom ridge as being 0.1 inches. Go up to the top, apply the same dimensions. I can say this is 1/4 inch, and this is also 1/4 inch. I can drag this back to the left, establish this distance up here as being 0.1, distance down as being 0.1, and that matches about what I have. Maybe I can shrink this down a little bit. Now I see that some of my lines are still blue. Easiest way to grab those and drag them around. I see that my height isn't yet set. Total height of this can is maybe, what do you think, 5 inches? Eyeball calipers. So let's dimension from the bottom up to the top. Now we have 5 inches. Okie doke. I now have a fully dimensioned cross section of the solid cylinder representing this can. If I go up to revolved, I now have something that approximately represents the shape of the can. Of course, if you were doing these for real, you would want actual dimensions. Easiest way to do that would be to buy a set of calipers. You can buy decent calipers on Amazon for about 15 bucks that are plenty accurate for at least the 3D printing machinery. The tighter your tolerances get, the better your tools need to be when you're measuring things. If you get up into precision calipers that are regularly calibrated and have some sort of licensing behind them, you're talking several $100s. But $15, Nico set of calipers on Amazon will get you an accuracy that is plenty good for the sort of work that we'd be doing in the first couple of years of school. Now here's the problem. This solid shape is all well and good for creating a solid that represents the can. Let's say you wanted to 3D print a cool koozie to go around your can so that you could carry your Bang energy drink across the park. That's something that you could do with a shape like this. You could use this to model the rest of your koozie for 3D printing. You could use this as a size reference if you were trying to figure out how many soda cans you could pack into your mini fridge in order to achieve optimum packing efficiency. The problem with this is that this isn't representative of the actual aluminum or tin in your can. We don't actually have this shape. We have a very thin wall around the outside edge of solid material. Everything inside of that is hollow. So if I go back into my sketch here, let's imagine for the moment that instead of closing all the way, that my shape should be enclosed with a center circle at the top, and that center circle is 1 inch across, let's just arbitrarily say. So think of it like we are creating a thin-walled vessel where you drink out of the center of the top, just because that's easier for the moment. If you want to create an extrusion that is revolved, that is, say, a couple of millimeters thin the whole way around, there are a couple of ways to do that. One way would be to continue on with the line tool and then just keep doing this for forever. The problem with this technique is that in order to accurately represent a single offset everywhere, where you could change the thickness of the walls with one dimension, you would have to add a bajillion construction lines. Like you would have to establish a construction line here and a construction line here, and then you'd have to establish a construction line here, and then a construction line over here. And in the case of trying to establish this case of the worst case scenario before we show you any sort of shortcuts, we could establish the offset once and then use the construction lines. Like, let's go with 2 millimeters thick. Oh no, that's not representative. 1 millimeter thick, that's much more better. Now if I apply the equal relation to all these construction lines, I can see, oh, maybe that's not quite right. Maybe like 0.02 inches. That's much more better. Now I could continue on with the construction lines until I have a perfectly defined inside edge of my can. But there's an easier way. If I go back to the drawing board, deleting all these inside lines, I could create thin material like that in a couple of ways. Option 1 would be something called a thin-walled extrusion. If you had a sketch like this, and I broke my extrusion, so I'll delete it. So go back to the sketch and try to extrude again. If I go up into revolved base from this thin line that doesn't enclose anything, Solidworks will pop up a window here that says, this sketch is currently open. A non-thin revolution feature requires a closed sketch. Would you like the sketch to be automatically closed? If I said yes, it would close the endpoints of my line. Earlier examples like the donut and the sphere would be just fine with an automatic closure like that. But here, that's not what I want. I don't want a line connecting my two endpoints. So I say, no, Solidworks. And it says, okay, well, if you're only extruding a line, I'm going to use something called a thin feature in the extrusion. So now it's going to extrude material that is thin around the center of the line. So if I created something that had a thickness here of 0.2 inches, for example, and then accepted it, what it does is create that thin material offset from the line. So it might be easier to see if I establish a cross-sectional view here. That is one option to create what we want. It's a great option. Another option would be to go back to the sketch drawing board and use a tool called offset. So if I highlight all my lines here, I'll deselect the construction line and then go up to this offset entities icon. Upon clicking that, it gives me an offset direction and offset thickness. Again, I could say 0.02, and I could reverse that, make that the inside or the outside, depending on what I'm trying to do. I could have it automatically close the ends with either an arc or a line. Line is more representative here. I could also have it split the middle with bidirectional and use that line that we drew as the center of the wall as opposed to either one of the ends. So now I have a closed contour, so when I go back into revolved base, I don't even need to mess with any of the thin feature stuff. I end up with the same result as earlier. So you have three options for doing that type of extrusion. One of them is very labor intensive, but gives you a ton of control. The other two are shortcuts, each of which has their advantages and disadvantages. The advantage of using the thin-walled feature within the revolved extrusion is that you have a very quick and easy solution. It's also easy numerically because it doesn't have to try to keep track of all of those additional lines. The downside is you don't have as much control as you do with the offset tool within the sketch. The downside there is now you have twice as many lines to deal with. Questions? What was that? We'll leave that for later. Yeah, we talked about them already. Yeah, we mentioned the first one when you guys were talking. It's understandable if you missed it. Other questions? Okie doke. So that can is a little bit of an extreme example, but if you were trying to model something simple like, say, oh, I don't know, maybe a cup, a real simple rectangular cup, all you actually need are two lines. You could say, I want the cup to have a height that is 100 millimeters, and I want the bottom to have a distance that is 50 millimeters. Then I establish an infinitely long vertical construction line wherein I'm revolving and creating a thin-walled feature, like, for example, this. Maybe a 2 millimeter thickness again? That probably seems right. And now you have a cup. Ooh. Ooh, what if we wanted to put a handle on it? That's a good question. If we wanted to put a handle on it, we have a couple of options. The simplest way to approach it would be to create a linear extrusion, something on, let's say, the front plane. Now you'll notice I'm drawing the shape of my handle from the center of the cup. That's going to be important in a second. Now I'll add some constructions to demonstrate the first option that we had talked about earlier. I'll say these lines and these lines should all be the same distance. So when I apply a single dimension, maybe 5 millimeters across, let's arbitrarily add some distance here. Maybe 1.5 inches. Now, total height, inside edge, maybe 2 inches, 2.5 to be safe. Then let's dimension that from the bottom, maybe 15 millimeters just for funsies. Now we have a fully enclosed region. If I were to create a linear extrusion that was also 5 millimeters in the midplane, all that doesn't look quite substantial enough. Maybe something more like 10 millimeters. That's much more better. Now we have a handle. This is one way to create a handle. There are more ways. You'll notice that when I drew my sketch I drew it such that the inside edge of the handle was actually on the inside surface of the cup. Why is that important to the way that we did this just now?
So it goes to the edge.
Exactly right. If I had started from the edge and then extruded out, the only part of the handle that would be touching the mug would be the point at the center of that extrusion. As the extrusion extruded linearly, it's going to get further away from the edge of the cup. So even this method is going to break if I extrude too far. Something like 50 millimeters here is going to be offset from the outside edge now. That's not good. We really don't have a handle on this problem now. Another way to do this, instead of creating a linear extrusion, would be to create another rotational extrusion like we had before. So if I go back into my sketch, I draw a construction line that is infinitely tall in the center of the cup. Now when I go up to revolved base, tell it I want it to use that construction line as its axis of revolution, and this time, instead of a blind extrusion, let's extrude in the midplane maybe 15 degrees. Now we have another handle, this one more hip or less hip, depending on your perspective.
What would you round the edges on?
Okay, a feature that we haven't talked about yet is called a fillet. The fillet tool automatically rounds over edges. So if I were to apply a fillet along all of these edges, maybe something like this. The reason that I don't like to talk about the fillet early on in our SolidWorks discussion is that people have a tendency to fillet the crap out of everything, which makes trying to grade homework that much more complicated because there's additional geometry to have to keep track of. But, you know, in the interest of science,
You gotta fill it with the inside edges.
oh, we're gonna.
Sweet.
Liam, I got you. That looks better. Let's add a really big fillet. Maybe something like this. That looks much more better. And that looks nice. That's a nice mug. It's nice. Exceptionally fragile and probably real uncomfortable to try to hold. But dang if it isn't nice. Other questions? Okay. So you'll notice in your homework assignment one of the things I ask you to do. Oh, look, there's a donut. Ha, that's fun. One of the things I ask you to do is to create a chess rook. So this chess rook has rotational symmetry, and then there are these notches at the top of the rook that you have to create. Well, one option would be to create them with a linear cut after you extrude it. Another option would be to extrude the entire shape and then have a linear extrude that extends out of the top of the rook. So, like, real rough approximation here. If I were to just create a completely ridiculous arbitrary shape that represented half of an imaginary rook, maybe something like this. And of course, you would have dimensions. So if you were to draw this shape like this, create a revolved base, aha, we have our rook. Man, that's a terrible rook. But it's a terrible rook that we made. So one option would be to draw on the front plane a notch, like, say, this. I can select the midpoint of my notch, tell it to be above the origin. I could apply a dimension that was just as arbitrary as everything else in this sketch that I'm creating. Actually, if I wanted to be a little bit more like the homework assignment, I could get rid of this height and just tell it to be collinear with the bottom of that top part of the rook. Now when I extrude in both directions, I have one of the notches. So I could repeat that process on the right plane as well, cutting out to create that shape. That is a way of doing it. Another way of doing it would be to create a sketch from the top view that was like a plus sign. So maybe something like this, where of course you paid much more attention to where the edges of your lines were, applied dimensions and relations such that this plus shape was actually representative of what you actually wanted and not this nightmare fuel of a plus that I've created. Now, yeah, it's okay. It's just a very nice looking plus. Now when I use an extruded cut and cut down to a surface, I can select the top part of the inside of the rook and create those notches in one feature. I'm guessing you're about to ask if you could create a single cut and pattern it. You can totally do that, but we haven't officially covered the pattern yet. Does that logic make sense? Okay, cool. Just like last time, the problem number 4 in your homework assignment is a choose your own adventure. All I ask is that it have at least one revolved extrusion. Anything that has at least one revolved extrusion will get a passing grade on that problem. Like, for example, that sphere that we created at the beginning of class. If there are 4 parts, and I'm asking you to submit 2 files for each part, how many files should you be submitting? 8, correct. There's 4 SolidWorks parts and 4 images. See you guys on Thursday.